That's a negative 6?
I get scared.
Oh, you already clicked?
Not yet.
Oh.
About to. Okay.
No. How you pause me?
I paused the whole class, so I'm going to start doing this just to give you a heads up I'm about to collect in the future. But yeah, I paused the whole class. A couple of quick things before I collect this data that I do want to mention. One, if you remember, we did lesson 6 before we did lesson 5 in here. My first block did the opposite of that. So they have a different set of bell ringers today based on where they are with the math than what y'all did because of where you are in the math. So I am going to record the bell ringer today. This lesson 5 that we are about to do, I've already done completely with my first block. So those videos are already on YouTube. If you search for them, just be aware they won't be today. I started lesson 5 with them on Tuesday, Monday or Tuesday. So you would have to look Monday or Tuesday to find lesson 5. Okay, so I just wanted you to be aware of that. I am about to collect. Man, y'all want to know something awesome? What? I think today is the first day that we've had all of us here in like 3 weeks. It's exciting stuff. I'm sure you were, but we got you all here, and I'm excited to have everyone here. Hopefully we can get group 5 to pick up their head and pay attention and engage in the conversation with us. Do what? That food puts you out?
You look like 5 minutes.
If I go to say, I'm tell you now.
So let's talk about this. All right. Write an equation of the function shown in the table to the right. I'll go back to the table in a second. I see a common theme for a lot of us. A lot of us are thinking that the y-intercept is what?
3. -3.
-3, -3, right? Okay. Hey, Brittany and Emily, I'm literally going over all these problems. I need you to pay attention. Thank you. So a lot of us are thinking that the y-intercept is -3. We see that here as well. Here, someone didn't think it existed. I see a +3 here and a +5. So we see some different equations. Now, I do want to point out, this indicates everyone so far thinks that this function is what type of function?
Linear.
Linear.
It might be.
Well, what I was going to say is, before you can write the equation of a function, you have to know what type of function it is. What defines the types of functions? Linear has what rate of change? An additive rate of change. Whereas an exponential would have a multiplicative rate of change. It's been a while since we looked at that understanding check, but be aware when we have a test next week, we will have a portion of that test that corresponds to those questions. Right? I gave us feedback on that understanding check so you could improve your understanding, and I'll even give you a chance to ask some questions next week to make sure you understand those different equations a little bit better. So if I were you, I would look over my understanding checks to make sure I know what questions I need to ask. But yeah, if we're going to say it's a linear function, or if we're going to write the equation, we need to know the type of function it is, or type of function. So the fact that we're agreeing it's linear means that we all saw what kind of rate of change? Additive, right? As soon as we see it's linear, as soon as we see it's additive, what's the equation we're dealing with?
Y equals mx plus b.
Y equals mx plus b, right? Now, this is where we got to be careful. What do we mean by m? Slope. But then how do we calculate that slope?
Rise divided by run.
There you go. Thank you for correcting that. Rise divided by run. Is there another way we could calculate it?
No. I don't know. No.
The change in x and change in y.
The delta or change in y divided by the change in x, right? Remember, the rise is a y direction, the run is an x direction, okay? So rise divided by run, or change in y divided by change in x. This is better when we have a table, because there's not really a rise or a run. That's more of a graphical idea. Okay, and then b is my what? Y-intercept, there we go. Now we need to be careful about that. Because I saw one person who said 5
Who did it?
for the y-intercept. Well, it makes sense though. Where are they getting the 5 from?
The first.
That 5 is the first point there, isn't it? Or the first y value?
Yeah.
Can anyone tell us why that is not the y-intercept?
Y-intercept is when the x is 0.
Right. Remember, the y-intercept is when we intersect the y-axis, and so the x value is 0. So I need to keep going backwards. So what's the previous x value that I could look at?
3.
3. The
3 is
previous
1.
y is,
1.
and then 0.
Negative 3.
Right? And so notice we're following the patterns, right? On the left-hand side, we're repeatedly adding 3. Right-hand side, we're repeatedly adding 4. Notice how there's the change in y is 4, the change in x is 3. What's the y-intercept? Negative 3, thank you.
Gotta be times 8.
So we gotta, well, I haven't written the equation yet, but what I'm trying to point out is we need to be careful. Is it 3/4?
No.
A lot of us probably looked at the x side and then at the y side, but remember it's change in y divided by change in x. I see one person has it correct here. Someone forgot the y-intercept there.
I forgot my change in X. That was good.
What's missing right there? The x, right? It's got to be an x in there. We've got to pay attention to our y-intercept. Okay, a lot of us did pretty well there, but again, be careful, right? It's -3, bless you, and then we need an x. So once we identify that slope, y equals 4/3
Times 8.
x times x, or x, minus the y-intercept of 3.
Let's do another one.
We all good on that one?
Yes.
Any questions?
No.
Going once? Going twice? Sold. Okay, so some of us just typed in the typed in x. Can x be the solution?
Yep. No.
No, definitely not. A lot of us are getting the 9 and the -3, so I'm going to go, and from what I could tell, a lot of us were doing this very correctly, but it also looks like we have 6, 8, 10, 11 of our 21 students who answered this question. That is problematic. That tells me we probably need to go over it.
Yeah.
Yes? Okay, so how about this in the future? Because I'm not showing off answers. If you have no clue or you got really stuck, give me at least a couple of question marks in there, and that'll tell me that we need to go over it. Instead of just completely leaving it blank, if you legitimately tried and didn't have a clue, put some question marks in there. Because I don't show you who said what, but I do go back in and look at this later so I know who to help with certain skills. Right? That's why I do this. Okay? What was the equation again? X minus 3 squared divided by 2
Plus 10, minus 10.
minus 10
Equal 8.
equals 8. Would anybody care to volunteer and say, hey, yeah, I didn't fully know how to do this? Can you talk me through some of these details?
I got you a little some.
You didn't know how to do it at all?
I got you a little some.
Well, I did know the.
Start by adding 10 on both sides.
Okay, so notice, and that's exactly right. We want to add 10 because that's going to make a 0.
0.
Remember, a fundamental thing for me, if I'm using inverses, the last operation being done is the first one I want to undo. Right? The last thing being done is subtracting by 10, so I add 10. And when I do that, and I got to do it to the other side to keep those equations what?
X minus 3 equal.
Not equal, equivalent.
Equivalent.
Right? Remember, they look different, but they're still the same. Okay? And then you already said this earlier. What are we going to do, Kyron?
We're going to multiply 2.
Multiply by 2, right? The inverse of that division is multiplication. That's the biggest reason why I don't want you to ever say over, is because we need to recognize that fraction is division, because then I know to multiply.
36.
That's why I got it.
Okay? So from here, Caleb, what are we going to do to solve at this point?
Right there.
Alright. Remember, the inverse of subtraction is addition. The inverse of division is multiplication. The inverse of a square is a square root.
I figured that's what we do.
Yeah. Notice the square root and the square cancel. And I've mentioned this before. Does anyone know what exponent it actually makes?
Well, I don't.
1.
Oh.
Remember how we've always created either a 0 or a 1. Taking that square root creates an exponent of 1. Okay? So x minus 3, now this is where we have to be careful. Braden, what is it equal to?
6. Or plus negative positive 6.
Plus or minus 6. We have got to remember, when we take that square root, there's 2 answers, a positive and a negative. Jordan's giving me those eyes like, dang, I totally forgot that, Mr. Kinney. Is that a good reminder? Did we forget it? Is it okay that we forgot it? Gotta learn from those mistakes. Alright, so Brianna, what am I going to do from this point to solve this equation? Have you looked at this equation?
I can't see board and take.
Seriously?
Look at me.
Yeah.
Okay, I need you to tell me that in the future. I'll try to make sure you have one of
Look
these
at the
front
board.
two
Tell
groups.
me.
+3. Good.
We are subtracting 3, so we're adding 3. -3 plus 3 is
0.
0.
Now, what I do want you to remember is, what that literally is saying then, is that x is equal to a positive or negative 6 plus 3. So what is a positive 6 plus 3? 9.
So it's equal to negative 9.
And, well, what's negative 6 plus 3?
Negative 3.
So, notice it's not just positive or negative 9, that's why it is a positive or negative 6, but then we have to add 3. If you want to, you can split it up as a positive 6 plus 3 and a negative 6 plus 3.
That when you do this.
And that's fine, you do what you want.
So
Right. If you feel more comfortable splitting it up like that and then finishing it up, or you could even do it from here, right? You could have said x minus 3 is equal to a positive 6, and x minus 3 is equal to a negative 6. If that helps you, go for it.
Can we do some more equations like this? What do you think?
Not today. We got other stuff to learn. Now, I will say we're going to do some stuff related to this for sure.
Just so we did yesterday.
Say again.
With the I and all that.
We will get back to the I soon.
I hope never.
Alright. So 3 minus the square root of negative 27. Man, we're all over the place.
Yeah, I'm gonna do how they started off with it, and I forgot
What
lost.
my answer?
Okay? So we did. I just need to kind of go over it.
Yeah,
Maybe.
I know that you.
I guess this is a good thing that we are looking at this problem as a bell ringer then. I thought we were good with it.
I knew.
Here's the thing. You can say I knew it yesterday, but if you don't know it today, did you fully understand it?
No.
No. And it's okay, but you need to be aware of that. This is the other reason why I asked you to do homework, so that you have time to try it on your own, and then that's why I give you a day to ask questions before the homework is due and say, yeah, I had no clue what to do here, Mr. Kenny. Cool, let's talk about it, okay? What's the first thing I need to do?
Find the square root of
Yeah.
I mean the real.
I need the what? I need the -1. Remember, what I'm looking for, what are those things called that are multiplied together?
What do things do?
Starts with an F.
Factors.
Factors. I'm looking for
Tell
factors.
me, I got it.
And one of the factors needs to be that -1, because what is the square root of -1? I.
Oh.
It is I.
It's me.
Okay, so that's one of the factors. Now, are there any other factors of 27 that I can take the square root of?
9.
3 and 9.
3.
3. So
Negative.
this would be 3 times
9.
9. Remember, from there, all it is splitting up your square roots into those different factors.
It's gonna be
Wait,
3
what was it?
minus the square root of -1.
Then 3 minus square root of 3.
Well, just times the square root of 3
Then it's square root of
times the square root of 9. I personally would write it out this way every single time. Mia, please take your headphones out. I would write it out as each square root every time, and then simplify from there to make sure I don't make a mistake. What is the square root of -1?
negative 1. Oh,
Remember,
Question.
that's the number I. Go ahead, a question.
Right here.
Yes, ma'am.
But that's negative 27. You want to make 3?
What?
That's like negative 27, right?
Yep. What's -1 times 3 times 9?
Oh.
-27, right? And so all I did was I split it up into those different radicals, but it's still the same. You good with that?
Uh-huh.
So that's the I. Can I take the square root of 3?
No.
No.
No. So it's times the square root of
3.
3. Can I take the square root of 9?
Yeah, 3.
So then that's just
3.
3. So then simplify it. So 3 minus, I typically put my 3 out front. Then you can do the I, then the square root of 3. I think technically it's supposed to look like this, but the order doesn't matter a ton. Okay? But I have my 3, my square root of 3, and my I there, all being multiplied.
See, right now.
Where? Oh, you had it written down? Then show it to me.
I ain't have time to add it.
Gotcha. Okay? Do we have any questions before I move on to the last problem? I can only help you if you're paying attention and asking
Read
questions.
about it.
Jordan, what's up, dude? What you staring at? Jordan. Pay attention. So, Jordan, you worry about you. I'll worry about everybody else.
You need to worry about these folks.
They made a choice. I'll take care of this when we start on a new.
These folks dropping like flies.
And it's affecting your active collaboration scores. Okay?
I have my head.
So-
I'm still collaborating.
You are.
If you got my head down, we don't sleep. God, don't try
I
that.
need everyone's attention on this, okay?
I did
Because
before.
this skill right here will factor into your ability to work through today's lesson. This problem right here will affect your ability to work through today's lesson. So we all need to have our attention on this.
Alright.
So I asked you to write the equation of a parabola with those roots that also goes through this point,
I didn't believe it.
okay? What should we immediately think about?
Vertex form.
Vertex form? Why do you say that?
Wait, no.
Isn't it?
Yeah, you know what I mean.
So that's what we need to pay attention to right here. It's going to be factored form because we have roots or x-intercepts.
Yeah.
When are we going to use vertex form?
When you have a vertex.
When you have a vertex.
Perfect.
Okay? So we need to keep that in mind. And so first things first, and because I am going through, first off, I gave you your understanding checks back. Please again notice, did I just put a score on the understanding checks?
No.
No. I gave you specific feedback based on where you were struggling or what details you needed to pay attention to. A lot of us don't even know, or at least on this understanding check, did not know the different forms of a quadratic equation. It's really hard to do these lessons if you don't know the forms of a quadratic equation. You got to study that. When I'm looking at, and I'll say this, when I'm looking at these graphic organizers, it's very clear that some of us just went to Google and Googled this stuff. Because I have a lot of students telling me that the vertex is x equals negative b divided by 2a. Have you ever seen me say or write that in class? No. So it's very obvious that we didn't use our notes. We just Googled that ish. Huh? At least they got it done. I'll agree with you. But here's the thing. Is that actually going to help you in this class? Yeah, but then you get a good grade on a 10-point homework just to then fail a 30-point understanding check or a 90 or a 100-point test. So what I'm asking you, hey, I agree that it's good they got one good score, but what I'm saying is you're putting yourself into a hole instead of literally just looking over your notes. You could go to the Desmos activity that you always have access to. You could go to lesson 4 from the textbook. It's all there. Use your resources. It'll help you. Heck, you could even go to YouTube and watch the video where I explain it. Yep, exactly. I explain it a lot. Here's my point though. You've got to know the forms and you got to know which features go with those forms. As soon as I see roots, I'm thinking about which form again? Factor. Now, a lot of us are trying to write the equation right away. Before you write the equation for this function, what do I recommend you do?
Whatever happened last, you do it first.
Now that's to solve an equation that's in first, everybody. Write the form of it. Write the general form with nothing being substituted in. What is the factored form of a quadratic equation?
A and then parentheses x minus r1 parentheses x minus r2.
I gotta ask, is Tristan the only one who I've taught
Yes.
this to? Oh, yeah.
She looked down.
No, I did. I'm the only one that
She
did
do
that.
that.
That was my fault.
Dang.
It's like she, paid attention when I taught this, I don't know, a week and a half ago. And maybe don't sit here and say that Tristan's the only one I've taught this to. Some people putting our heads down or putting our heads inside of our shirts or inside of our hoodies specifically instead of paying attention when Mr. Kenny's teaching. Yeah. And I know Jordan knows this pretty well because I think Jordan's been pretty actively engaged the last week or so. But also I need you to get involved in this conversation. When Kanye is willing to open his mouth in the whole class discussion, he almost always gets it right, but he's too scared. And then I got some students like Anaya who I know it, but are dead asleep. And Jane's all shut down because I put him in his group 5. He's salty with me. Yeah. We'll fix it in a second. Okay. I mean, if you want me to move you, you will. Okay. You can stay there.
I will.
Alright, so- What is R1 in this case?
3, well, I changed to a positive
That's not what I asked. What is R1?
3. Negative, your x-intercept.
It is an x-intercept, but what is this R1?
Negative
Negative 3.
Negative 3.
Okay? Well, you said 3. And there's a reason why I'm asking you to identify negative 3.
Okay.
Okay? I'm going to come back to it in a second. What's R2? 4.
4.
I recommend that when you write this equation, just substitute it in like that to start. Now, do I know what A is?
No.
Nope.
No.
Times x minus negative 3. I recommend starting there because a lot of us are messing up if it's supposed to be a positive or a negative or whatever it is. When I subtract a negative though, what do I get? Positive. So write it like this to start. Oh, I'm subtracting a negative, so I'm going to make it a positive, a plus. Times x minus what? 4. I don't need to change that because it's just minus 4, so I'm good to go. Write it the way it is. Identify R1, R2, and substitute it in and simplify if need be. You think we're supposed to stop with that A though?
No.
No, I'm supposed to know what A is, right?
Yeah.
Well, I've already used these roots. So, Kanye, what do you think I still need to use?
Yeah, the English.
Is your name Kanye? I didn't realize you grew like 2 feet all of a sudden.
I changed my identity.
Oh, okay. So remember, Kanye, I've already used this. What do I need to use still? Huh? That 2? Okay, so what am I going to use that 2 for? What could I do with that 2? The x? Remember, it's alphabetical order, right? X comes before y. So that 2 is going to be substituted in for x. That's an x value. What's this negative 20 going to get substituted in for? Why? Oops. How many variables do we have now?
1.
Can you solve an equation with one variable pretty easily?
Yes.
That's it. Negative 20 is equal to a times 5 times negative 2.
5 times negative 2 is
Negative 25.
5 times negative 2?
negative 10.
Negative 10.
Negative 10. So I got negative 10a. What am I going to do?
Plus.
Oh, you can divide by negative 10 on both sides.
Yeah.
Okay.
I did that.
So 2 is equal to a. Now I know what a is. So f of x equals 2 times x plus 3 times x minus 4. That's it. You got to recognize that I'm going through that point, so I'm going to substitute in my x, I'm going to substitute in my y.
So, y'all,
You know what?
that's it from there?
I mean, I asked you to write the equation.
Oh, not solved.
Do I have that equation?
Yep.
And that's an important distinction. Did I ever ask you to solve it?
Can it be solved though?
It depends what you mean. If you mean, can I find the roots or the zeros? Yes. But remember, I already told you the roots. So you wouldn't need to solve it. Does that make sense? Yeah. So, yeah. All right, let's get back to today's lesson, or get to today's lesson. First things first with that lesson. Nope, that's not y'all. Yeah. So we got a chance for you to ask some homework questions from that lesson 6 that is due tomorrow. And then we're going to get to lesson 5, the root of the problem. So I think this is, oh yeah, the right portion. This is part of the homework that's due tomorrow. Are there any of these terms that we don't feel like we covered well and we need to ask questions about? This is lesson 6. This is lesson 6, somewhere around M1 dash, I don't know, 112 or so.
113.
113? Man, I really literally guessed that. So, thank you for, I did. I knew that lesson 6, or I knew lesson 5 was somewhere around M1 dash 90. So I guessed. Alright. Are there any of these things that we need to talk about? It's lesson 6. Oh, it's literally on the board.
I didn't see, I knew you cheated.
I didn't look at it. I should have.
What's the
I said the
paper?
same thing.
It's up on the board.
I I can't see that.
And you're not even trying to see it.
Oh,
Which one? Okay. Are there any of this from the right portion that we need to ask questions about?
Use this, and then do the bottom.
It should be pretty well in the lesson that we can find it, but I'm
Pure
more than willing
imaginary.
to answer any questions.
Yeah, pure imaginary.
Pure imaginary.
Pure imaginary? This one right here? So, remember, what is a complex number?
oh,
Okay, but how do we write a complex number?
A plus B.
Thank you, a plus bi.
Oh my god.
That is a complex number. That is literally the beginning of lesson 6. Which part of that complex number is the imaginary part?
The I.
Not just the I,
B-I.
Does anyone see any of the numbers that deal with bi?
Three.
The term bi in a complex number written as a plus bi. That is the pure imaginary number.
Uh-oh. We got the brains.
Ooh, hold on a second. I lied.
Oh, trick me.
I did.
So I ain't got no brains.
Sorry.
I thought it was 2.
No. So there's somewhere else that we have bi. Look again.
7.
7.
The term
Yeah, the
complex.
number of the form bi. So that's the pure imaginary number. Sorry. I did
Wait,
not finish looking.
what's the difference between 7 and 3?
That's a great question.
Let's see.
So look up here. Does anyone? Yeah, that's 6, not 7. If anybody was saying 7 accidentally. The number of the form bi, where b is a real number, that's the pure imaginary. So I want you to think about this.
Wait.
We just said that bi is the what? Imaginary part of what?
A complex.
Does anybody see that anywhere up here? What did y'all just say it was?
Imaginary.
Imaginary part of a what?
Complex.
Thank you.
Oh.
Boom. Literally, he said C originally, but notice that's the imaginary part of a complex number. That is G.
So that 3.
Okay?
3G. That's so funny.
Okay, are there any of these other ones that we want to go over?
One more.
Oh.
One more.
4?
That's dumb,
That's
Jordan.
B.
Oh, come on. Really? 4?
I'm trying to help.
Come on. So, please someone tell us what 4 is.
4 is B.
Yeah,
B.
I've had that.
4 is the number I, Jordan.
It's F.
I know. Okay, so I mean, look. If 3, the term bi in a complex number, is the imaginary part, if bi is the imaginary part, what is the real part? Thank you.
So what number is that?
Use your eyeballs.
Yeah, I can't.
Sorry, Robert's trying to act out because I shut him down so hard earlier.
Yeah.
He's still feeling the burns.
I'm about to come back.
Alright. Any of these others that we legitimately need to ask questions about?
Oh,
I've already given you half of them. I feel like from here we
oh no,
should.
not right, but.
Definitely looking at the practice still. Yeah. Okay, so looking at this practice. Well, I mean, I've already given you one from the bell ringer.
What?
Oh, the B one.
The B.
Yeah, 1B. We should know how to do that one.
Let's do it again.
I'll pray about it. Alright. Which of these do we want to talk about?
D.
We just got to have a bell ringer.
2A. Okay.
200.
Does anyone have an idea how we might like what is the most specific set that A falls into? So think about the number sets. Is it a natural number?
It's rational.
Is it natural? No. Is it a whole number? Is it an integer?
It's a weird.
No. So is it a rational or irrational? Which one?
Irrational.
Probably.
Rational. No.
So remember, a lot of times when we have a square root, it's irrational. But
You got a
do we
real
know what
number.
the square root of 9 is?
Yes.
3.
3.
It's a real number. 3 is a real number.
So that is a what kind of number? Rational number. So remember, just because there's a square root there doesn't automatically make it irrational. Right? Because I can take the square root of 9 and get it's a perfect square, that is now a rational number. It's a ratio of two integers. That's why it's called rational. So if it's rational, what else does it fall into? And by the way, you can use the symbol or write the word out. So it's rational, what else? Okay, so the next thing above rational is real. And if it's a real number, it is also complex. So it's rational, it's real, and it is complex. That is 2A. So, good little reminder. What is what symbols? So remember, the symbol for rational was the Q. The real, it was the R. For the complex, it was the C.
You can give us a little help, 1D.
1D? Okay.
Oh, everybody, where?
So, 1D, 5 plus the square root of negative 20. How am I going to get started?
You can do 5 plus the square root of 5 or negative 1. What? I'm gonna call you nice,
Times what?
5.
Negative 5 or 5? 5
Times 4.
times 4.
Right?
So, negative 20 is negative 1 times 5 times 4. Now, why do y'all think Nia chose 5 times 4 instead of 2 times 10?
Because she decided to choose that number.
The real, gotta get on.
We gotta get,
Can you take the square root of 4?
I know.
The real.
Right? So remember, what we want are those perfect squares. So she chose 4 instead of 2 and 10 because I can take the square root of 4. So 5 plus the square root of,
I.
not square root of I, square root of negative 1. Okay. Remember, the square root of negative 1 is I. Square root of 5 times 2. And so you can write it how you want from there. Do try to put that real component, real rational component out front. 2 square root of 5 I is how I prefer to see that. Okay? Hopefully that gives us enough to get started to go from there. No? Number 3? I didn't assign y'all number 3.
1C.
It was just 1 and 2. That's why, yeah. That's why you were struggling. I did not assign number 3. Yeah. Alright.
No.
I'm not erasing it yet. It's still up there. Okay? I'll go back but we do need to get going.
Everybody's homework should be done. We did most.
I mean, we've done half of it, right? Like, good grief. What?
Robert said you don't have credit. Oh.
Alright, ready to move forward? Going once, going twice.
Sold to Mr. Kenny.
That's right. Okay, so don't forget what we've done is we've already kind of talked about the complex number sum. Sorry, I just realized Fernando's still writing it down. But while he's writing that down, we've already talked about the complex number sum, and that's because we're going to have to get into the complex roots. And we're going to talk more about the idea of roots with lesson 5. And it will help with one of the terms on that right portion of lesson 6. So, here's the thing. This is what we looked at yesterday. We're going to use graphs. I mentioned this at the end of class, that there is a process called factoring, very algebraic. There is a process called completing the square, very algebraic. But we're not going to do them that way. We're going to use graphs to determine the roots of quadratic equations. Because what do we have in our hands that can easily graph for us? Calculators, right? As a quick reminder, even when you get home, because I don't think anyone in here has brought their computer, but one, I can download the software for the TI Inspire on a computer if you bring that. But 2, what do you have online? Desmos, right? You can use Desmos on your phone, on a tablet, on a computer, whatever, right? So Desmos is a great graphing calculator. We're going to use those graphs to rewrite quadratic functions in forms that reveal key characteristics and to factor quadratic trinomials. We're going to use graphs to rewrite quadratic equations in, hey, what form is that ax squared plus bx plus c?
Vertex form.
Nope.
And
Ax squared plus bx plus c, we need to know is standard form. We're going to rewrite it into vertex form. And what do I need to get vertex form?
Standard form.
Say it again. I need a vertex to get vertex form. So the standard form we can use a graph. And we're going to learn about something called the quadratic formula. Okay? So I want to say this really clearly, and I need you all to listen to this. Up to this point in the class, in this unit, we have had 5 equations that we have learned and need to know. What are those 5 equations? That's not an equation, dude. That's a number. Standard form of a... So you need what kind of equations or functions are we studying? Quadratic. So standard form of a quadratic.
And
Vertex form and factor form.
Vertex form of a
quadratic. And factor form of quadratic.
factor form of a quadratic. And this is well, hold on a second. It's important to recognize they're of a quadratic because there is a standard form of a linear as well. Right? So standard form depends on which type of function. But what are the other 2 functions we've studied? Exponential and linear. So you need to know the equations for those 5 functions. You got to know them. You got to study them. You got to know what those different values mean. But we are going to introduce a new equation, the last equation, a 6th one called the quadratic formula. We're not there yet. But we are on 5.1.
What's page number?
I don't know, like 80 something. 81. 81?
You gonna be wrong about this one?
That was a guess. That was an approximation.
I thought the first one.
Okay. I thought the first one was, I just already had it on the board, so I didn't need to guess. Alright, so this is where we started. We briefly touched on it yesterday, and I need you to make this note to yourself before we get started, or before we get too far into this. As I said before, algebraically you can use a process called factoring. We're not going to do that algebraic process, but I do want you to notice that the first thing they did in this equation was they added 3. Why did they add 3?
Question.
Because there was a, yeah, I don't know.
Thank you. Negative 3 plus 3 is 0. Come on. Come on. I know you can do that. You gave up on yourself. That's why I'm frustrated.
Wait.
So x squared minus 4x plus 3 is equal to 0. Hey, what's another word for a root?
Square root.
Zero.
Hey, what are we equal to right now?
Zero.
0. Okay. Another word for a root is a 0. Hey, that's a 0. What's another word for a root or a 0 though?
Square root.
I'm on the x-intercept. Thank you. Roots, zeros, x-intercepts. They're not exactly the same, but they are very close to the same. And I'll tell you the difference later on. But that is important to notice. Now, again, what form do we have right here?
Yes.
We have standard form, right? What process did I say earlier that they do algebraically? They factor it, right? Does that make us think about any forms we may have studied? Factored form, right? So we want factored form. We don't have the factored form. What do I need to write factored form? Two what? 2 x-intercepts, right? Well, how am I going to get those x-intercepts if I want the factored form? What did you say, Jordan? It is quadratic. Say it again, Ralston.
graph.
Can we find the x-intercepts on a graph?
Yes.
So I need you to remember and pay attention to the objectives, because what did I keep talking about in the objectives just a slide ago?
Graphs.
Graphs. Yep, there you go. Okay? But legitimately, I need y'all to pay attention to the fact that, hey, I have standard form. What's the only thing revealed in standard form? What features do we know from the standard form?
Graph.
Did you say 1?
The y-intercept?
Okay, remember the y-intercept we can tell from standard form. My y-intercept is 0, comma 3.
0,3.
Remember, there is my standard form. Those C values my y-intercept. What else can we tell from standard form?
If it's concave, that go down.
Thank you. Concavity you can always tell, right? So we want to pay attention to the fact that we can do concavity and y-intercept, but we don't have the x-intercepts, so we have to graph it. So everybody pick up your calculator. Graph that equation to make sure we can get our x-intercepts and our factors.
Oh, you change. Oh, I ain't done. What you doing? Oh, I'm gonna take it.
Hit menu for me real quick. Go back to the Windows Zoom. And just zoom so it's back to what it's normally supposed to look at. Hey guys, if the window is super far off from what you're used to seeing, you can hit Windows/Zoom and do Zoom standard. You can whine about it some more.
Mr. Kim.
What's the issue? There you go. Type in that equation, yep. Huh?
X squared minus 4x plus 3.
The orange equation right there.
I need some glasses.
Hey, my login was successful.
All I did was for people A. I don't know. Wait, plus, what, minus? Oh, where's my bag?
I'm up.
So
Where'd it go? I'm getting
X2 minus 4x plus
I think it's both.
Hold on one second.
How you get rid of the equals?
You don't? Why would you get rid of the equal sign?
What the world? It's not even tripping.
Okay, what is the equation? X squared.
Minus 4x plus 3.
Okay. You should have that graph. If you don't, let me know.
I got it.
You don't do equal 0.
You don't set it equal to 0.
Oh!
Sorry. Let me clarify, right? This is the equation. I need all eyes up here. This is the equation we're trying to solve, but we're just trying to rewrite this part in factored form, right? So I don't put the equal 0.
I got it.
All right? It is just the x squared minus 4x minus, or plus 3 that I'm getting in there. Work with your group quickly. Actually, first off, let me say this. What do we need again in order to write factored form? I need the, well, I know the concavity, but be careful. I need to, before I even get there, we're trying to do factored form. What is factored form?
As in like the equation?
The general equation.
Oh, then it's
It's R1.
It's what? The R1 is involved, but that's not the equation.
X minus R1. I got it. Times X minus R2.
Okay. So, two things I'm trying to emphasize this and remind you every time. Before I try to write my factored form, I'm writing that down every time. Every time you write that down and you remember, hey, this is factored form, it's going to help you remember it better. Every time you write that equation or that expression, you're going to remember it better. There's a connection between your brain and your hand. When you write, you remember it better. Every time you write it. So, first off, I do want to point out, I don't need to know the concavity for the equation. I need to know the what?
Yeah.
Sorry, what I'm referring to right now is A. A controls the concavity, but that is not the concavity, right? If A is positive, it's concave up, and if A is negative, the parabola is concave down. But that's not necessarily concavity. What is the A for this equation? We should already know.
It's positive.
It's not just positive. Is it a positive 20, a positive 1/2?
Three.
Not a positive 3.
It's 3.
Remember, what is the letter that we're talking about?
Hey,
A. And what is the standard equation? Ax squared plus bx plus c. That 3 is my c, my y-intercept. Hey, look, there's my y-intercept of 0, 3. What is A? What do you think it is, Jordan? 1? What's understood to be in front of this x squared?
A 1.
A 1, right? So that A is a 1, which you don't have to write that, but it is good to note that A is 1. Quick thing I want to show you is this. Does anyone know how I can still identify the roots even when they may not be easy to see on the graph? This one should be easy to see, but there's a way to identify the roots every time. No? Couldn't remember if we had talked about this. I thought we had. What one button do most of the operations run through on the calculator?
Menu.
Everybody hit menu. I am trying to do what to this graph to get those roots? Go to analyze that graph. Anybody see another word for roots or x-intercepts?
Zero.
Okay. I need everyone to have their head up, and I need you to do this. Otherwise,
We did it.
I thought we did this. Okay, thank you. I was like, I know. All right. So, well, remember, we're not trying to find the vertex. We're trying to find the roots. So, we did the lower bound and then the upper bound to get the x-intercepts already. If you're struggling with this, let me know later. But lower bound. Nope, that's not what I wanted. Menu, analyze, 0. So in case you didn't already know, what's one x-intercept?
3.
3 is the one I have right now. And 1. Does anybody need me to go back through how I got those x-intercepts?
Yes. One more time.
How y'all told me we did this?
Well, some people have memory loss.
It sounds like an excuse. I mean, it sounds to me like some people have not hard-working issues. Alright, so we're going to go to 0. What is the first question to ask? Lower bound. Okay, bottom left-hand corner, that calculator is asking us for the lower bound, which means we need to be to the left of the x-intercept that we want. And then you hit enter. Now, what question is it asking? So I just scroll to the right of the one x-intercept that I want. I don't go too far. I don't get the second x-intercept. I just get the first x-intercept, and then I hit enter. I go through that process again to get my second x-intercept. Yeah. Hit Control Z. Do it again. Hit Control and then Z. One more time. Control Z. See that? How did you do that? There it is. You may have, you just have to hit Control Z there until it gets back. Okay, or just graph it again. Alright, does anybody need me to go back through how to get the other 0, or can we do this?
We can do this.
Caleb, you good on getting x-intercepts? Braden, Emily, Kelsey? Are those the x-intercepts? Is it where that function is crossing the x-axis? Okay, cool. Alright. So here's the thing. Now that you have your x-intercepts, what is the factored form? X minus?
R1.
What is R1?
1.
I mean, does it really matter which order?
No.
You just have to have both of them, right? I typically go from left to right, just because that would technically be R1 times X minus 3. Remember, that's the factored form, right? I had standard, I got my x-intercepts to get factored form. I want you to notice here, is that the same thing we have in the book?
Yes.
Yes.
Uh-oh.
They went through an algebraic process, we're just doing it graphically. What I need you to notice is this though, because I know that some students are not going to listen to this and they're going to make a silly mistake. We have to be equal to 0 to use the factored form. Please make this note here. The standard form has to equal to convert to and use factored form. The standard form has to be equal, you should probably include, no, it has to equal 0 to convert to and use factored form. If you are not equal to 0, it will not work. If it is not equal to 0, it will not work. Now here's why. This, remember, is critical to understanding why we have to equal 0. The zero product property states that if the product of two numbers, if two or more factors is equal to 0, then at least one factor must equal to 0. What that literally means is, if I have a times b equals 0, what do you know about either a or b? Either one of them, or both of them, equal what? 0. That is the zero product property. If I have two things being multiplied, and they equal 0, at least one of them is 0. Now, if I have a times b equals 4, do I automatically know anything about a and b? The answer is no.
No.
It's equal to 4. A could be 1, and b could be 4. A could be 4 and b could be 1. They could both be 2. They could both be -2. They could be -1 and 4. Do you see how there's lots of different options when it's something other than 0? But when it's equal to 0, at least one of them is what? 0. That is why we have to equal 0. Because if this thing is equal to 0, that means that x minus 1 is equal to 0, and we can say that x minus 3 is equal to 0. If we have factored form, we can set each factor equal to 0. I would write that down.
So what do we need to write down?
If
Hold on.
we have factored form equal to 0, if we have factored form equal to 0, you can set each factor equal to 0.
Each factor equal to 0.
If we have factored form equal to 0, you can set each factor equal to 0. Do I need to repeat that for anybody?
Yeah, one more time.
If you have factored form equal to 0, then you can set each factor equal to 0. Okay? Notice from there, it's pretty easy to solve each of those equations. X equals 1, and x equals
2.
3.
okay.
Oh, 3.
3. So, I forgot that we already talked about this. Y is 3 added to both sides in the first step of the worked example,
Property. So you get 0.
so that we can get a 0, so we can use what property, Caroline?
Property of no.
What property?
The 0.
There we go.
When did we talk about that?
You were asleep.
Like literally less than 5 minutes ago. So number 1, y is 3 added to both sides, so that the right hand side is 0, so we can use what property?
The 0 product property.
There we go, the 0 product property.
Yeah.
Alright. So once again, we have to equal 0 to use the zero product property. Now, is it safe thing to say that you need some practice time doing this on your own to see if you fully understand it? The answer is yes. So, use factoring to solve each quadratic equation if possible. Now I need you to hear me on this. Okay? That's what we just did. What form do we currently have?
Standard form?
Standard.
I mean.
Oh, that's standard?
That's as standard as it gets. What form do we want?
Factor.
We want factored form. So what do we need?
To do what we just did, to
They already
find
equal
that.
zero.
Why do we graph it though?
Because we need our x-intercepts.
We need x-intercepts. Remember, go back to what you're saying. We have standard, we want factored, so we need to equal what? Or we need to equal 0, and then we need our x-intercepts. Work with each other to get your x-intercepts, to factor that out. I'll come around and check on us. We'll have a whole class conversation about it in 10 to 15 minutes. Let's get to work.
I said add graph back.
Plus 12.
Boom. I got it.
But you also need to learn to work with the people you're with.
Gotta-